Okay, we're going to start chapter 15 today. We're skipping over 14 for now with the hopes, fingers crossed, that we come back because chapter 14 is way more complicated than 15. So we're hoping we're going to do the easier stuff first and go to that one if we have to. Okay, so chapter 15, we're going to start with right triangle problems. Yay, you've been dealing with those for a while. I did attach the notes for this day. You do not have to print them out. It is definitely not necessary. You can take notes on your own paper, but if you want to, you can print out the attachment that I included for today's notes. All right, so let's review some right triangle trig. Yes, we've got a right triangle here, a little square in there to say, yep, it's a right triangle. And if you remember, if this is your angle theta that we were talking about, right, sine and cosine and tangent are trig functions of that angle, then I know that the side opposite, like if you're standing in that angle and shot an arrow, this would be the side opposite. The adjacent side is the one touching it, and the hypotenuse is always the longest side. And that's that one there. And if you remember SOHCAHTOA, so stood for that sine of theta is equal to the opposite side over the hypotenuse side. And CA was cosine of theta is the adjacent side over the hypotenuse side. And TOA is the opposite over adjacent. And of course, you also learned these with X, Y, and R, where X was your adjacent side or the horizontal side, your opposite side was Y, or the vertical displacement or distance, and then hypotenuse was R. And so these same guys in terms of X, Y, and R, sine is Y over R, you should have that memorized. Cosine is X over R, and tangent is Y over X. Just to relate what you already learned with those. Okay, so first example says, let's find the other side in angle measures for the right triangle where angle C, where the right angle is angle C, and angle B is 22 degrees, and then side C. Do you remember that the capital letters are the angles and lowercase letters are the sides? Yes, so I'm going to redraw my right triangle and label them A, B, and C. It told us C was the right angle. Angle B is 22 degrees. Now, and side C is the side opposite of angle C. So side C is 33. So that's what they gave me. And hopefully you remember that opposite angle A is side A and opposite angle B is side B. Hopefully you remember that. All right, so now what they want us to do is find the other side and angle measures for triangle ABC. Side, I guess it should be find the other sides, since I need side A, I need side B, and then I'm only missing angle A. Let's start with that. The measure of angle A is 3 angles in a triangle add up to 180. So 180, 180 degrees minus the right angle is 90 degrees, and then angle B was 22 degrees. And when you subtract those, you'll get 68 degrees. Let's add in the directions that we're going to round to 2 decimal places when we need to. Obviously, I didn't need to do that for the angle, but for the rest of them, I might. All right, so to find B, well, I know the hypotenuse, right? And so if I use sine, this is for 22 degrees, that's the one I know. I know that side B is the opposite side. I know side A is the adjacent side for angle B. Now, could you use angle A? Yeah, but what if you made a mistake, right? I always try to use the information given. All right, so here's what I know. I know that sine of angle B, 22 degrees, is the opposite side, which I labeled as side B, over the hypotenuse, which we know is 33. And so how do I solve for B? Multiply both sides by 33, so that side B will equal 33 times sine of 22 degrees. And when you put that in your calculator, yes, you need your calculator. You need to make sure you're in degree mode. And 33 times sine of 22 will give me 12.362. And so I will say 12.362. The 2 will say leave that 6 alone. And so 12.36 is what I will say B is equal to. And then to find side A, I know angle B, and that's the side adjacent. So cosine of angle B is equal to side A over the hypotenuse. Well, that'll give me A is equal to 33 times cosine of 22 degrees. I'll put that in my calculator. So 33 times cosine of 22, and that gives me a 30.597. All right. Going to here, that 7 says round it up. Well, then that rounds that up too. So I'm going to say side A is 30.60. Not too bad, right? Hopefully. All right, let's do another example. Find the other side and angle measures of the right triangle UVW, where the right angle is W. All right, so let's draw the picture. UVW. And side U is, so side U will be over here. Little u, is 439.8. And side V, which will be this side, is 641.2. So I need to find side W, and I also need to find these angles. All right, so let's start with angle U. This angle here. So what I know about U, I know that for U, this side would be the opposite side, and this side would be the adjacent side. So I can use tangent. Tangent of angle U will equal 439.8 over 641.2. And so for U, the measure of angle U, will be inverse tangent of 439.8 over 641.2. And you'll put that in your calculator, making sure you're in degree mode still. All right, so I got inverse tangent of 439.8 divided by 641.2. I got 34.446. And so that'll tell me angle U is, I'm going to go to 2 decimal places whenever I need to, so 34.45 degrees. All right, so there's angle U. All right, now how do I find measure of angle V? Well, I know W is 90, and I know angle U now, so we just do 180 degrees minus 90 degrees minus the answer I just got for U. And so angle V will be 55.55 degrees. All right. I'm not picky about do you write the measure of angle V or whatever. Doesn't matter. All right. How am I going to find little w? Well, I know the side and that side. So I'm going to use Pythagorean theorem. And that says that the hypotenuse squared is equal to u squared plus v squared, side squared plus side squared. And so that will give me 439.8 squared plus 641.2 squared. And remember, you'll take the square root of that. Let's see if I can get it all on the same screen. There we go. Okay, so I'm going to do square root of 439.8 squared plus 641.2 squared. And I took the square root of it, and so you'll get W is about 777.535, which means I'll say that W is 777.54, rounding to 2 decimal places. No degrees on that one because that was a side length. It wasn't an angle. There you go. All right. Go to the next page. Angle of elevation and depression. Well, okay. So let me remind you of something. Okay. Do you remember that if you have two parallel lines cut by a transversal, right, then this angle here is equal to this angle here because of alternate interior angles. Well, this angle here is what we call the angle of depression, because it's like if you're up on top of a cliff and looking straight out, you're looking down to see like this point here. But versus this guy here is if you're standing down at the bottom and you're looking up, so your horizon is straight ahead and then you're looking up, it's the angle of elevation. Is this guy here. You're looking up to this spot there. All right, so that means that the angle of elevation is going to be the same as the angle of depression. And that's because of alternate interior angles are congruent. These two guys are congruent. Okay. So it says when the sun's angle of elevation is 38 degrees, a building casts a shadow of 45 meters. How tall is the building? Okay, so then when the sun's angle of elevation is 38 degrees, the building casts a shadow of 45. So what it's saying is you've got this triangle. Let's say this is, you've got 38 degrees, right? You're looking up towards the sun, and then here's this building, right? And the shadow that it's casting is 45 meters. And we want to know how tall is this building. I'll say X, but it's really Y, right? But it doesn't matter. Okay. All right, so that's the information I know. And this is the side opposite. And this is the side adjacent. And so we're going to use tangent. Tangent of 38 degrees is equal to opposite over adjacent, multiplying both sides by 45. And that will give you about what? 45 tangent of 38. 35.157. Which means if I go to 2 decimal places, like the directions tell me to, then I would say it's 35.16, and then meters was the unit. All right, now, next example says from the top of a lighthouse. All right, so let's pretend I'm not a good artist. You guys know this already, but let's say here's my lighthouse. Whatever. All right, so from the top of the lighthouse, 20 meters tall. So this guy is 20 meters. And from the top of here, I'm going to draw a dotted line, a sailboat is sighted to have an angle of depression of 4 degrees. So angle of depression means it's like this. And let's say here's the sailboat. Angle of depression there, 4 degrees. Now, all right. So I know that this guy is 20. I know that's 4 degrees. How far is the lighthouse from the lighthouse is the boat? They want this guy here. And what I know from up here, angle of depression and elevation, that this 4 degrees is the same as the angle of elevation. So the angle of depression from the top of the lighthouse to the sailboat is the same as the angle of elevation from the sailboat to the top of the lighthouse. So that's 4 degrees also. All right. I've got opposite and adjacent, so that's tangent of 4 degrees is equal to 20 over x. Multiplying both sides by x, I'm going to show this out because it comes out differently than before. Multiplying both sides by x, you would get a x times tangent of 4 degrees is equal to 20. So those x's canceled. Whoop, whoop. And then you're solving for x, so divide both sides by tangent of 4 degrees. And put that in there. Here we go. 20 divided by tangent of 4. 286.013. And I'm going to 2 decimal places. That 3 says leave that 1 alone. 286.01 meters. All right, next example. A meteorologist measures the angle of elevation of a weather balloon as 31 degrees. All right, so let's say here's the meteorologist, and he sees this weather balloon. Whatever. My balloon looks like a light bulb, but whatever. Okay. Say there's a weather balloon. And so they're saying that this angle of elevation is 31 degrees. So from where he's standing to seeing the balloon is 31 degrees. A radio signal from the balloon indicates that it is 100 meters from his location. That means that's that distance. How high above the ground is the balloon? We want x. All right. So what do we have here? I've got opposite and hypotenuse this time. Opposite and hypotenuse. So now I'm not going to use tangent. I'm going to use sine. Sine of 31 degrees is x over 100. Solving for x, you just need to multiply 100 times both sides. That's 100 sine of 31. 51.503. All right, not degrees, sorry about that. And going to 2 decimal places, I would say 51.50 meters again. All right. Yo, try one on your own. Yeah. The library needs to build an access ramp for wheelchairs. The main entrance to the library is 8 feet above the sidewalk level. If the architect designs the slope of the ramp in such a way that the angle of elevation is 5 degrees, how long must the access ramp be? All right, pause your video. Pause your video right now and see if you can try this on your own. Pausing. Pause. All right, hopefully you paused and come back. What does the picture look like? All right, the main entrance is 8 feet above sidewalk level, and they want this ramp. So let's say here's the ramp, and 8 feet above sidewalk level, that's the height right there. The slope of the ramps is such a way that the angle of elevation is 5 degrees. How long must the access ramp be? They want to know the hypotenuse now. And so that should have been, you should have done sine of 5 degrees is 8 over x, which would have given you x multiplying by x dividing by sine of 5 degrees. And you should have gotten 91.789, which will give you 91.79 feet. All right. Hopefully that made sense. If not, come see me in office hours and I can answer any of your questions. Have a fantabulous day.